Okay, we're going to look at product rule. It's very easy. Okay, if you have two functions, you've got you call the first one u, the second one v. Then if you want to differentiate it, you're going to combine them in the following way. So you're going to have v u dash, so you differentiate u and multiply it by v, plus u v dash, and that's easy. So add, and then you've got one differentiated multiplied by the other, and the other one differentiated multiplied by the first one. It's very easy. So you have to be dealing with product of two functions. So for example, you could have sine x multiplied by cos x. Why not? So you're going to pick one of the functions. Clearly there's product of two functions. One is going to be sine x, and you pick the other one, cos x. So on the side, differentiate it, you'll get cos x. Differentiate this one, you'll get minus sine x. And then use this formula to work out what dy dx is. So effectively you need to multiply the sine x, so which is cos x multiplied by cos x. So it's cos x times cos x plus, and then you're going to multiply sine x by whatever cos x multiplies by. So sine x multiplied by minus sine x. So you'll get cos squared x minus sine squared x. Great. Let's have a look at a different one. Okay, we're going to look at product rule. It's very easy. Okay, if you have two functions, you've got you call the first one u, the second one v. Then if you want to differentiate it, you're going to combine them in the following way. So you're going to have v u dash, so you differentiate u and multiply it by v, plus u v dash, and that's easy. So add, and then you've got one differentiated multiplied by the other, and the other one differentiated multiplied by the first one. It's very easy. So you have to be dealing with product of two functions. So for example, you could have sine x multiplied by cos x. Why not? So you're going to pick one of the functions. Clearly there's product of two functions. One is going to be sine x, and you pick the other one, cos x. So on the side, differentiate it, you'll get cos x. Differentiate this one, you'll get minus sine x. And then use this formula to work out what dy dx is. So effectively you need to multiply the sine x, so which is cos x multiplied by cos x. So it's cos x times cos x plus, and then you're going to multiply sine x by whatever cos x multiplies by. So sine x multiplied by minus sine x. So you'll get cos squared x minus sine squared x. Great. Let's have a look at, so here's a different one. You've got e to the power 5x multiplied by 7x minus 1 cubed. Okay, so you've got a product rule because there's a product of two functions. So quote it. Even if you know it by heart, it's always a good idea to quote it in your exam. So you do not need to know it by heart, but the first function is e to the power 5x. And the next one is 7x minus 1 cubed. So what you've got here, you have got two functions, but they're not as easy as in the example before, like you had sine x and cos x. They actually are composite functions themselves, but we've got to be able to do that quick differentiation, I call it quick chain rule, without any problems. So this one you should know because that's from last year anyway. E to the power 5x goes to 5e to the power 5x. And v dash, so here you've got this quick chain rule that we talked about before. You've got inside function, which differentiates to 7. and you've got the outside function, which differentiates to 3 of the outside of the bracket to the power of 2. So I'm going to put my 7 first, and then I'll have to put 3. Let's just do this one in blue so you know where it comes from, but I won't be doing colors. To the power of 2, and the inside is 7x minus 1. So it's 21 and 7x minus 1 squared. You combine them in this order, okay? So dy dx will be vu dash, so these two times together, although I'm saying v first, when I'm multiplying it, I'm going to put 5e to the power of 5x first. This looks awkward at the end of the bracket. Plus, and I'll multiply these two together. So 21 times e to the power of 5x times the brackets. That's how I'm going to put it. But you can put it in any order and then just have an extra line of workings tidying it up. Now, you may just leave it like this because you are asked to find the value of dy dx, or you might need to be able to factorize this expression. So you should really be pretty good at this because you've done some sequence work before. So whatever is common here, I like to circle it, and that will come in front of the bracket. So I'll pull out e to the power of 5x, but I also have 3 of 7x minus 1 brackets multiplied together, and here 2 of them. So 2 of them can be taken out. So that one I've highlighted it, so I won't have 3 anymore. I'll have just 1 left. So that will come out. And what's left need to be put into a bigger bracket and tidied up. So you'll have 5 left from the first term, but also 1 of the brackets because I've used 2, and then plus 21. So it's e to the power of 5x multiplied by 7x minus 1 squared, and then you've got 35x, and minus 5 plus 21 is plus 16. Check whether you can factorize this bracket further. You can't, so that's it, you're done. Okay, let's look at one last example. Let's call it f of x is equal to, what shall we have? Let's do a trig function and bracket. So let's have 3 cos 5x, and then multiplied by 4x plus 3 to the power of a half. So it's a square root. Okay, so let's just copy our formula. So it's vu dash plus u v dash. Okay, we're going to identify our u. So I'm going to call my u's 3 cos 5x, and v is 4x at 3 to the power of a half. So I need to carefully differentiate this. This will go to minus sign, but you will have to multiply it by 5. So the 5 and 3 will get together and you will have 15, but it's minus 15 because it's of the cos going to minus sign. So the inside function does not change here. V dash. Okay, so here again, we'll have to multiply by that 4 here. Let's put that here. I will also need to bring the power down, and you'll have 4x plus 3 to the power of minus a half. So that nicely cancelled, and you'll have, you could write it as 2 over 4x plus 3 to the power of a half. If you bring it to the denominator, I'll leave it as 2 4x plus 1 to the power of minus a half. Okay, so let's just combine them. vu dash, so you have minus 15, you have sine 5x, and you will have 4x plus 3 to the power of a half, plus you're going to have 3 I'll write it slowly. 3 cos 5x multiplied by 2 over 4x plus 3 to the power of a half. Okay, so let's copy this one down. Minus 15 sine 5x multiplied by 4x plus 3 to the power of a half. And then plus, so here we're going to have cos, well, 3 and 2 multiplied together give me 6. So 6 cos 5x over 4x plus 3 to the power of a half. And you might want to just bring it to the common denominator in order to see what it looks like, simplify it further, I guess. So you would have to times this one by 4x plus 3 to the power of a half, because you need to think of it as having 1 in the denominator, and this, the top, also by 4x plus 3 to the power of a half. Okay, so I've got one big denominator of 4x plus 3 square rooted, or to the power of a half. And here we'll have minus 15 sine 5x, and then 4x plus 3, and then plus 6 cos 5x. There you go. I guess the only thing you could do here, I'm not liking that bracket at the end of sine. It looks better if it's put in here, and maybe put the positive term first. So 6 cos 5x minus 15 4x plus 3 sine 5x over, let's put it as a square root, 4x plus 3. I think that's all we could do. Good. Okay, let's have a look at the last rule for differentiation. It's called the quotient rule. This rule actually appears in the formula booklet. It's you need to, though, memorize it. It's very, very easy. In the formula booklet, I'm pretty sure it's in terms of f of x and g of x. So you need to have a quotient of two functions, so one divided by the other. And you take the derivative of the function, high function, or the function on the top of the function, multiply it by the second function, so the function in the denominator, and then you subtract, and the reverse happens. So you take the function on the top and multiply it by the derivative of the bottom function, and then you need to square the bottom function, and that's what goes in the denominator. The easier way to remember is to go to our u and v notation, so u over v. If I'm asking you to find the differentiated answer, so the derivative of the quotient, remember it the way I ask you to memorize the product rule. You put v first, and you put vu dash minus uv dash over v squared, and this way you could see the v's are happening on the outside. So you've got v on the outside, then you've got v with a dash. It's not 1, it's a dash, but then you've got v with squared on the bottom, so they make v shape. Okay, and here it's like a product rule but with a minus. If you accidentally put a plus, you will not get any marks. If you swap the way the taking away is happening, again you're going to lose all accuracy marks. Okay, so we're going to have a go at an example. So let's see what happens. It's if I have to differentiate, let's say y equals, and we'll have cos x over e to the power of x. Okay, so quote the quotient rule you recognize is the division, the top function, so your u. Always write this down. U is equal to cos x, and v is equal to e to the power of x. Then you differentiate those two functions, so u dash is equal to minus sine x, and v dash remains as e to the power of x, and then you combine them in that order. So dy dx is going to be given, I like to put my v squared first, so e to the power of x all squared. We'll rewrite it simply in a minute. And on the top you're going to have VU dash, although I remember as VU dash, you know, I'm going to just, actually let's write it down, minus sine x times e to the power of x. You can do it in either order as long as this is just for memorizing it, minus these two times together, so it's cos x times e to the power of x. So let's definitely tidy it up. If you were to write this one, you could have written it e to the power of 2x, but if you could see that e to the power of x appears in both terms in the top of the fraction, I will factorize it out. And then on the bottom I've got e to the power of x all squared. I'll rewrite it as e to the power of 2x. That cancels. So I've got 1 here and e to the power of x left. Let me write the answer over here. So you may want to put minus in front of the fraction and then write on the top of the fraction sine x plus cos x and then e to the power of x. Okay, so this is like taking minus 1 out of that bracket. You wouldn't put minus in the top with a bracket in the top of the fraction, so you wouldn't necessarily write it like this. It's better to stick that minus in front or leave it as both minuses like this. Okay, let's do another example, maybe a little bit more interesting. So let's have example 2. So you just make it more difficult by introducing harder functions. So let's say we've got to differentiate a square root of 2x plus 1 over, and let's have on the bottom of the fraction, tan 2x. There you go, why not? Okay, so first of all, quote your quotient rule. So it's an alphabetical order, u on the top, v on the bottom, and you start with vu dash minus uv dash over v squared. Okay, so my u is going to be, let's prepare that function for differentiation straight away, to the power of a half, and then v is going to be tan 2x. So if we differentiate this function, you've got a chain rule. So you've got something to the power of a half. So in the inside function is going to be raised to the power of a half. So you bring the power down, it's a half. Then you've got 2x plus 1, reduce the power by 1, so it becomes minus a half. And then you need to differentiate the inside function, so times 2. The half and 2 will cancel, and you are left with 2x plus 1 to the power of minus a half. V dash. Okay, so this one, again, you've got tan, and the inside function is 2x. Tan differentiates to sec squared, so it's going to be sec squared 2x. Remember, the inside function won't change, multiplied by 2, because 2x differentiates to 2. The answer is 2 sec squared 2x. Okay, let's combine them in the right order. So dy dx. Let's do the denominator first. So tan 2x, you will write tan squared 2x or tan 2x all squared if you prefer. And then we are going to do vu dash. So this function multiplied by that function times these two together. So let's put the bracket first, 2x plus 1 to the power minus a half multiplied by tan 2x minus, and then let's multiply this one by this one, so these two times together. So again, let's do the bracket first, 2x plus 1 to the power of a half, and then you've got sec squared 2x. Okay, in terms of tidying it up, it's just you might want to get rid of the negative power. The one way of doing it is rewriting the top expression with 2x plus 1 to the power of a half in the denominator. Or another way of doing it is by multiplying the top and the bottom by whatever would make this go away. So 2x plus 1 to the power of a half. I'm going to go for that approach. So if I multiply that one by 2x plus 1 to the power of a half, I need to do the same to the bottom of the fraction, 2x plus 1 to the power of a half. Okay, so on the bottom of the fraction, I will have 2x plus 1 to the power of a half multiplied by tan 2x. On the top, if I multiply these two together, the 2x plus 1 to the power of minus a half will cancel with 2x plus 1 to the power of a half, because it will become 0, power of 0. So you are left with tan 2x minus, if you multiply these two together, you're going to end up with 2x plus 1 multiplied by sec squared 2x. Okay, we're going to leave it like this. You might want to write it as a square root. Later on you will learn how to replace sec squared with tan squared, learning new identity, but I think for what I need you to show, that's enough. Okay, so you're now ready to do some questions on quotient rule.